Hey, this is Mike. This video is part of a series where I will go through some super fundamental concepts in math. The reasons why I call this series one step back, two steps forward is sometimes when we are stuck, we have to fix the fundamental issues in order to reach new heights. I think the title says clearly what it's meant to be, but to give you an idea of what to expect, please take a look at the following equations and ask yourself, do you have any hesitation in solving them? If you do, this video might help. If you don't, please come back again for another video. I value your time. With that said, let's begin. First, let's take a look at these two equations. I'll give you a few seconds to solve them, and we'll talk about what we get. With only a few seconds, these are the solution I'll give. If you can get the final answer, that's great, but it's not the main point here. Now I want you to ask yourself honestly, did you think at any point the equation on the right is any harder than the one on the left? The reality is, for the first equation, we subtract 3 from both sides to get the answer. And for the second equation, we subtract 1 over 6 from both sides to get the answer. They share the same pattern. For people like me who have solved hundreds of thousands of equations, we have learned to see patterns instead of the actual numbers. However, for others who are still learning, it might not be very intuitive. One thing I would like to highlight is, very often I have seen students solving equations like this. Instead of focusing on the process, their minds simply search for the correct answer. Since they remember doing 4 plus 3 before, so they can find the answer. But if we change the numbers to decimal or fractions, they fail to do it. Remember, the solving equation technique is meant to work regardless of the numbers given. I'm going to show you some examples with numbers most people are not comfortable to work with. However, you can see that in each example, I'm doing the same thing by subtracting a suitable number from both sides of the equation. So, takeaway number 1, focus on the process, not the result. It will help you tremendously when we move to more advanced algebra courses. Next, we're going to look at another pair of examples. I'm going to show you the solutions, but one of them is wrong. Which one do you think is wrong? The answer is the right one is wrong. And I'll use this example to look into the bigger issue. First, let's try to illustrate why one equation is right and the other is wrong. To make the two equations more alike, let me first change the way the left equation is written. To solve these, we can indeed go through the same process of multiplying both sides of the equation by 4. However, for some reason, students tend to forget that every term needs to be multiplied by 4. If we do it properly, we can see in the end they give different answers. So, what's the catch? How can we avoid making these mistakes? For one thing, we need to remind ourselves when we multiply or divide both sides of the equations by the same number, we do this to every term. Very often, we get lazy about the rules and we see x divided by 4, we just multiply that term by 4, but not every term by 4. Another thing I want to remind you guys are sometimes you may hear people say something like, we have division by 4 on one side, so we move the 4 to the other side and do multiplication. Please be very careful about this moving a term to the other side. In reality, we don't have such operations. It's only the end result of some other operations. I think the key to avoid making these mistakes is to go back to the basics when we are confused. Allow me to go over the four basic options we have when we solve an equation. They are simply adding, subtracting, multiplying, dividing both sides of the equation by the same number. I would say at elementary level, 95% of the time, you're doing one of these four operations. Remember, don't do things you're unsure of. Slow and steady win the race. The last advice for my video is probably the most important and hardest to master, but with practice and dedication, you can do it. When we say multi-step equation, it can also mean it is a series of one-step equation. That's why the key to do it is to find a suitable unknown for every step. Again, we will take a look at an example. For this equation, it's obvious that x is our unknown, but to find it, we have to deal with times 4, minus 9, and divided by 7. It's not straightforward. Say, for example, if we treat 4x as a unit and call it our new unknown. The equation looks a bit simpler because we only need to deal with minus 9 and divided by 7. To some students, this could be challenging at first, so some visual aid could go a long way. I recommend you prepare some erasable highlighter so you can temporarily target another unknown. How about we treat the entire 4x minus 9 over 7 as the unknown? Obviously, it doesn't help because there's nothing to solve for. So targeting something too big doesn't help. I hope by now you can see by treating 4x minus 9 as our first unknown, we can solve for this in one step by simply multiplying both sides of the equation by 7. Once we have done that, we look at the equation again and treat 4x as the next unknown. We can solve for it easily by adding 9 to both sides of the equation. Eventually, we can solve for the value of x. This is a basic example, but it does highlight the mental trick that we use to solve an equation. Every step of the process, we are solving for something else, not x. Some students find it easier to grasp this idea. If you find it difficult, you are not alone. Please try to use some visual aids like I said before. The next example I'm going to show you is actually not a linear equation. You are not supposed to fully solve it until you do a more advanced algebra course. However, I want to show you what you're doing right now will lay the foundation for you to progress into the more advanced topics. Let's see it in action. In this equation, even though you may not understand what 2 to power x means, but I think it should not be too hard to understand we can treat 2 to power x as an unknown. Like the previous example, we take 2 to power x plus 7 as our first unknown. After that's done, we treat 2 to power x as the new unknown. Once it's done, 2 to power x is equal to 4. That's it. Even if you haven't learned what 2 to power x is, you are almost there at the final answer. To recap, the final takeaway for you is if you can't see what to do when solving an equation, use a visual aid like a highlighter and try to treat your equation as a series of one-step equations. Before I go, I want to let you know what part 2 of this video will be about. It will mainly cover situations where the unknown appears more than once like this. It will also cover situations where you have to perform operation that involves the unknown. The example I've shown here, we have to multiply both sides by x rather than a number. So, if you are interested, please stay tuned. Thank you very much for watching, and please like and subscribe for more maths content and study tips in general. See you soon.